Now question number 76. For given mass of an ideal gas at constant temperature, these options are given. So when we talk about for the given mass of an ideal gas at constant temperature, the law that we should follow here is Boyle's law. And what that states? It says that pressure of the given mass of an ideal gas at constant temperature is inversely proportional to the volume, or simply we can say this PV is a constant value. And if you look at the given option number 4, that states PV versus V graph is a straight line. If you plot PV versus V, then you will find a straight line parallel to the x-axis. We are plotting this PV versus volume. So this PV versus V graph is here, and in this case we are obtaining a straight line. That is why option 4 is the correct option, and I'm just marking here the correct answer that is given in option 4. Now let's take the next question. Question number 77. A closed cylinder contains 40 gram of SO3 and 4 gram of helium gas at 375 Kelvin. If the partial pressure of helium gas is 2.5 atmosphere, then the volume of the container is. The value of R is also given. So in this case, we have two different gases. One is sulfur dioxide, other is helium. And we just want to find out the total volume available there. That can be calculated by calculating the volume of helium gas, because that volume is available for both of these gases. And that we can obtain with the help of ideal gas equation, that is PV is nRT. In this case, we have the pressure of helium as well as we have the amount of helium also to calculate the moles of helium. R is given and temperature we also know, that is 375 Kelvin. It means we can find out the total volume occupied by the helium, and that is actually the volume of the container. So pressure of helium is given, that is partial pressure 2.5 atmosphere. Volume we just want to calculate. Moles of helium, amount of helium is given, that is 4 gram divided by its molar mass, 4 gram per mole. R value is also given, 0.082 liter atmosphere per Kelvin per mole. Now let's multiply temperature here. What is the temperature? That is 375 Kelvin. And here this V value you will find out simply, that would be 0.082 into 375, and that would be divided by 2.5. If you solve this, you will find out that this is 12.3 liter. And if it is the answer, we can easily choose the correct option, that is given in option 4. After this, let's take next question. Question number 78. The suitable thermodynamic conditions for a spontaneous reaction at all temperature are. Basically, we know that the process would be spontaneous when this delta G value is negative, or we can say this delta G value is less than 0. And one more thing, delta G is equals to delta H minus T delta S. That's the relation that we use to find out whether the reaction is spontaneous or not. So in this case, the two values are here, delta H and delta S. The question is, you just have to find out that condition which is there for the spontaneity at all temperatures. It means irrespective of temperature, the reaction should be spontaneous, and in that case, you just want to find out the value of delta H and delta S. If you look at this given reaction, you will see that delta H minus T delta S, that is equal to delta G, should be less than 0 in this case. And this can only be happen when this delta H is negative and delta S is positive. In this condition, whatever be the temperature, always this delta G is less than 0. And that is the condition for spontaneity. And that's why we can easily choose option 2 as the correct option. And after this, it's a turn for question number 79. Question number 79. At high pressure, the compressibility factor for 1 mole of van der Waals gas will be. It means just observe clearly that we're talking about van der Waals gas. It's 1 mole you have and pressure is high and you need to find out the compressibility factor. What is that compressibility factor? That is Z and it's a ratio of PV and RT. So ratio of PV to RT is Z. Now, if you're talking about van der Waals gas, definitely we'll apply van der Waals equation. And what is that? For 1 mole of the real gas, the van der Waals equation becomes P plus A by V square pressure correction. Then V minus B should be equal to RT. This is the formula that is used for the real gases. Now, in this case, we know that pressure is very high. That is why this value of A by V square is negligible. So this value we'll assume negligible because pressure is very high. That's why the formula that we consider here is PV minus B is equals to RT, or we can also represent it as PV minus PB, that's equal to RT. And now if you divide both the sides by RT, then this would be the equation. And now it can also be written as PV by RT, that is equal to 1 plus PB by RT. And what this value represents, this PV by RT, this is the Z value. And if it is Z value, it means you know the compressibility factor where it is given. This 1 plus PB by RT is given in option 3 and just choose it as the correct option. Now, it's a turn for next question. Question number 80. The most probable speed of an ideal gas at constant pressure varies with density. It means you just have to relate the most probable speed of an ideal gas with density at constant pressure. First thing, that what is this most probable speed? This is equal to root 2 RT upon M. This is the formula that we use to calculate UMPS. Now, in this case, we should also know that the relation between density and the pressure of the gas is P is equals to dRT by M. Now, what would be the value of RT? The value of RT would be PM by D. You have this value of RT. Just take this value from here and place in this equation. So, this UMPS would equal to 2 PM by M into D. So this M would be cancelled and finally this value would be 2P by D. So how would you relate this UMPS with density? You can say that at constant pressure, right here, at constant pressure, this UMPS, that is most probable speed, is inversely proportional to root D. And this is the desired expression that you need here. And on the basis of this, you can easily choose the correct expression that is given in option 3. So let me write here option 3 as the correct answer. And after this, question number 81 is here.